So here, to start to do the table that we wish to do as an example of the component or a family, which is going to be done through a parametric way, I'm going to go with File, New, Family there. And then among all the template that we would be able to use for a target component, again, we're going to go with metric generic model. So make sure to find the metric generic model, click on open. And again, there we are with another metric generic template, right? So first step is to always set up our unit. So press UN, that window will show up, press there and make sure to be on meters. Right? Click on OK, another OK, and we're done for in terms of unit. Now this time, we're gonna go like more systematically, meaning that we wanna define some sort of reference planes so then we would be able to set up parameters while we're doing the modeling part. So the first part that I'm gonna do, I'm gonna define some sort of guidelines. So the surface or the plate of that table, it's gonna get fixed to that, right? That's only for the purpose of parametering. So gonna go with reference plane. I'm actually right now on reference level. Gonna select reference plane and start to define the reference planes. As you can see. And then what I'm gonna do, I'm gonna go with create again, gonna go with extrusion, and then define a rectangle which is getting based on those reference planes. So gonna get starting from here all the way to the other corner, and then make sure to lock all the lines to the reference planes like that. Once I'm done with it, I'm gonna click on finish, as you can see, and then start to define the align dimension for the further purpose of parametering. So gonna click on align dimension, and then I'm gonna select the reference planes. For example, one click is gonna be here, the second one is gonna be on the middle one, and the third one is gonna be on the ending part. Then I have to be clicking somewhere in the middle. So gonna click there, and gonna select that EQ part, which is supposed to make those parts equally, right? And another one is supposed to be from here to there. So that is the actual dimension between these two reference planes. And then by the help of this parameter kind of thing, we'll be able to set up an equal space, equal band between them. I'm gonna do the same thing here. Again, make sure to put on the EQ part. And here. That's it. Now, what I want to do is to name those align dimensions so I can have a parameter. So gonna click there. Gonna go with create parameter. Once you click there, that window will show up. So for example, one side, I'm just gonna put it as A. Then you can either go with type or instance. So depends on you whether you wish to have your parameter getting appear all the way up on your properties tab or into your edit type. So if you wish to be appeared on your edit type, then you have to go with type. However, if you wish to have that like easily accessible on your properties tab, then you will be able to go with an instance. I want to stick with the type. So gonna click on OK, and as you can see right now, we have a parameter that is defined with A equal to the length that we have. Gonna do the same thing to the other dimension that we have. So click there, create parameter. This time I'm gonna put it as B. Again, gonna put it on type as what it is. And as you can see, I'm all okay with what we have here, common length dimension. So you're all good. Click on OK. And that parameter also got happen. So as a check, what I can do is to go on that part, which we call that family type, right? Click there, and that window will show up, right? A and B. So what I'm going to do, I'm going to change these values. For example, if I want to put it as 1.20 and click on apply, as you can see, equally, both legs of the table will get into each other. Let me do that with the other part of it. I'm going to put that part as 2 meters and then click on apply. As you can see, again, equally, the 2 legs of that table or the 2 edges of that table is getting towards together, right? So that's the way how we will be able to define first the work plane here that is essential. So then it could be the base of the table plate here, right? Then we have to start defining the parameters. Also, it is super important to first define an equal dimension that way, right? So then we will be able to order Revit to make sure to always change the size equally from the both sides. Then we have to define an overall parameter from, let's say, one side to other side and make sure to define that as a parameter, right? So that's it for the plate of the table. Gonna click on apply and okay. So far we have reached that part that we would be able to define the reference plane and then define the extrusion and make sure that the extrusion is getting locked up with that reference plane. So once we define the parameters, right, like that way, then we would be able to change the distances between the reference planes. So the extrusion that is already locked up to that reference plane, they have to follow the reference plane that we have. So I would say the reference plane is kind of dominant. So whatever sort of change is getting happen to the reference plane, without any other choice, the table or the extrusion part should be following. Now I'm gonna put my visual style on consistent colors so we can better see the form that is just shaped here, right? So we are all fine with that plate that we wanted to place from our table. Now, what is important from here is to define other part of the table that we wish to have. So first of all, for example, I'm gonna go on front. As you can see here, I'm gonna select the extrusion that we just did and put it, for example, somewhere starting from 0.8 to 0.90, right? So that is the table plate that we have. Now, what I want to do, I want to define another reference plane that we have. So I'll go with reference plane. For example, I define a random reference plane here. And then I want to make sure to use an align tool so then that part is getting locked up to that reference plane. So click there and click here and make sure to lock that up. Once that is done, then we would be able to add on 2 different align dimension. The first one is going to be from here to here, so make sure to only select the reference planes. The second one is from here to the other part of the extrusion that we just made. I'm going to place it here. And now again, we have to define them as a parameter. So the first one is going to be, for example, thickness. Again, gonna go with type, click on OK. And the second, also you can change the scale so then you can better have the tags and let's say the text here. So I'm gonna put it as 1/10, so it's like much more easier to work with them right now. And then gonna click on the other align dimension that we have, create parameter here, and then put it, for example, as H, which represent for the height. Right? Again, gonna go with type, click on OK. And as you can see so far, we're all good with the height of that table, right? And the thickness of the plate that we have, right? All good. So now, once we are done with that part, again, we will be able to give a try to the parameters that we have. For example, if I wish to change the height, for example, I want to bring that. Let's first change the thickness that we have. For the thickness, I'm going to bring it back to 0.10. Click on apply. As you can see, that part is getting happen. And then for the height, what I want to do is change the height to 0.5 and click on apply. As you can see, the height of the table is getting changed. However, the thickness of the table is not getting changed, which is the purpose, which is the aim of, let's say, a parametric modeling. So if you have set up, let's say, the parameters in a proper way, then you wouldn't be you don't need to be worried about changing these parameters, because nothing happens. Everything would be in a proper order. So whatever sort of like value that we can put on the height, we still have this peace of mind that the thickness is not getting changed unless we change the value, right? So gonna click on apply, gonna click on OK, and again, I'm gonna get back to the ref level. Now this time, I wanna define these supports and make sure that the supports can also follow up the parametric modeling. So what I wanna do, gonna go on create, gonna go with extrusion again, and this time I want to define the support boundary here. So I'm going to go with the pick line here. And for example, I want to make sure that I'm like every time that I define and let's say a support, I'm actually like 0.10 meters distant from the corner of that table. So I go with the pick line and put on the value of 0.10 and start to select the path here. Once that is done, I will start cutting the lines or trim and extending them with the trim extend tool here. Click there, and as you can see here, we will be able to make sure that the lines are getting trim and extend that way. Once that is done, then I can bring my point viewer on the boundaries, press on tab so you make sure that all the lines are selected. Then you would be able to use the mirror option. So use the mirror option. For example, one, I'm going to have it from here, so it's equally getting placed on the other side. Again, press on tab, hold on your control, and then select the other boundary so both of them are selected. And then again, I'm going to go with mirror option, as you can see. So in terms of the defined boundary, we are all fine. I just need to define my align dimension. So here, unlike the table plate, we're not getting off the order and then defining the boundary. I'm defining the boundary right here where I am. So gonna go with the align dimension. As you can see, that leg or that side of the support with the reference plane. So for example, one is gonna be here, the other one is gonna be here. Or let me do that part. So both of them would be 0.10. Also, when I reduce my scale, so I would be able to better see stuff here. 0.10, 0.10, we're done here. Let's do that with here. You should do the same thing for all the supports that we have. Like that. So once we are done with all of them, what I can do, we can select simultaneously all the aligned dimension that we have. And then define them as a parameter. So go all the way up. And then, for example, I want to define it as support DIS for distance. So I know what are the distance for my support always. I'm going to click on OK, and the parameter just got defined. Again, another type of dimension I'm going to define, this time for the area, or let's say for the length or width, or if I consider that as in square, let's say the size of the support. Here, 0.10, 0.10, gonna click there. So I want to consider that as in square. Like that. And then again, we have to select all the dimensions and make sure to define them as a parameter. For example, I'm going to put it as support DIM dimension. Click on OK. And again, as you can see, we just define parameters for both the distances and the size of the support. And now we're all fine to click on finish. Once that is done, then I'm going to go again on front where we just defined the other parameters here. And then I want to make sure to use align. Select that reference plane as a reference, and then for the second click on the top part of the extrusion, which we know them as the support, and make sure to lock them up there. So whenever the height is getting changed, also the height of the support will accordingly getting changed. Now what I want to do, I'm going to go on ref level. I want to put this as wireframe and give it a try to see what will be the parameters here. So gonna go again with family types here. For example, for the support dimension, I wanna put on as 0.20. So instead of having only 10 centimeters as the, that is actually the size of the support. So instead of like being 0.10 for each side, then it's supposed to be 0.20 like that. Then the support distance, instead of 0.10, I want it to have 0.20, as you can see here. Also, let's change the size of the table. So instead of 2 meters, I want to have 2.5, as you can see. Instead of 1.20, I want it to have 2, as you can see. Let me go on the 3D part, so we can better see stuff here. I'm going to select on that thickness, click on find, select that thickness, and here you would be able to hide that. So I'm going to hide that element and click on, well, it's fine to be like that. Now again, I will be able to bring, let's say, a list of the parameters that we have, and then again start to change the parameters. For example, the thickness, I want it to have 0.5. The height of the table, I want it to have 0.8. Right? So you will be able to change whatever you wish. 1.8 times 2.20. Or let's say the support dimension be 0.15 and the size would be 0.15 as well, as you can see. So we actually planned or designed a 100% parametric table that we would be able to put it as a coffee table, as a dining table, or at any sort of like usage or function that you wish to have. So you don't need to create, let's say, different versions of the table. So that way you would be losing like tons of time, right? Instead, we would be define a table with those parametric options or tool. So then whenever we just manipulate these parameters, we would be able to end up with different forms or shapes of, let's say, a table. Last but not the least is defining or setting up the material parameter. So to do that, I'm going to select the table plate and the supports all together. And here, as you can see, we have material. We would be able to assign here right now on spot a material. However, that material would not be able to get applied on an actual project. To make sure that we would be able to always follow up and set up the same parameter, same material parameter in an actual project without the need of getting back and forth to that template, we would be able to set up a parameter. So how we would be able to set up a material parameter is to select all what you have. And it's really important to select only those parts that you wish to have the same material. Since I want to have the same material for all the supports and the table plate, I'm going to select them all. And then from that small rectangle just next to the parameter, the material parameter, so click on there and then create a new parameter. So for example, I'm just going to put it as mat. Then again for example, this time I'm going to go with instance. So I can change the material always on properties. Going to click on OK. another OK. And then as you can see, right now you wouldn't be able to change the material from the template because it's locked up to the actual project. Once that process is done, I'm gonna save the table, or let's say the family object that I just did. For example, I'm gonna put it as parametric table. Right? Click on save, and then either loading to project and close or loading project. I'm gonna loading project and close. And then place it somewhere in your project. Now that it's here, I can select that table, I can go on the edit type, and I can see all those formula that we just defined there. So for example, the size of the table I wish to be 2 by 1.5 with the height of 1 meter, with the support dimension or size of 0.10 and support distance of 0.10 again, and the thickness of 0.5. Click on apply. So that is the table that we get. Also, we define the material parameter on the properties. We put it as instance. For that reason, it's not getting to the edit type. It's already getting appeared on here. So click here, and then as if like you're having an already existing component in Revit, the material window getting popped up. Here you can, for example, search for an parameter for a material, or you can define your own material here. I'm just like assuming that material is only going to get assigned to the table, so I'm not going to define any other new material here. For example, the cherry one, going to double click on there, and as you can see perfectly, it's getting happen. It's fully parametric, so meaning the size could be changed in whatever sort of like value or like dimension that I wish, and also the material getting changed too. So that's all you need to know as an example to set up a parametric family object in Revit, and put it in your project and use it as much as you wish, with different sort of function. One time like as a coffee table, the other time as a dining table, or let's say whatever sort of usage that you wish to have. So to show like what is the difference between the parameters that we just defined it as an instance or as the edit type. So let's say for that component, I'm going to select that component, go on the edit type, and change these values. 1.5 to height 0.9, and that's fine. Click on apply, click on OK. And here, as you can see, both the tables at the same time getting changed because I didn't duplicate the component, right? Since I didn't duplicate the component, whatever sort of like value that I changed also got to happen on the other same component that we have here. However, if I change the material here, let's see if like the other component which has the same nature getting changed or not. So gonna click there, and this time instead of cherry, for example, I'm going to go with another type of wood. For example, that one. As you can see, the other component is not getting changed in terms of material. Why? Because the material parameter is listed under the instance at the time that we defined this parameter on the template that we were working with. For that reason, as you can see, the material is not getting changed for the other component. So that is the difference between an instance or an edit type of material. So I hope you guys find this video useful, and please don't forget to subscribe if you haven't done it yet, as I'm always constantly updating the contents to make sure that you guys are getting to learn new stuff and tricks. Thank you.